So if you look into this dashboard, essentially what you're seeing over here is the top tile, or the where it says issue detail, that is kind of the piece which we call as the autonomic Wi-Fi, whereby this system is actually collecting data 24/7, sending it to the cloud in a secure mechanism, and then the AI engine and the cloud analyzes that data, figures out what the problem is, and then tells you potentially a resolution to that as well. And you can, for, again, the experts, this may seem, very, okay, I already know all of this stuff, but there are cases when you are, again, doing all of this thing remote, right? If you're doing all of this troubleshooting remotely, that's when this can be helpful, right? So standard stuff, but you can, and all of this stuff, you can look at real time, and you can also look at historical data over there as well. I can go back in time and say, okay, tell me yesterday, a week ago, 30 days ago, what was going on, and you can click on any data point over here and see what was actually going on. And any even standard stuff like, I know, channel overlap, we all talk about it, I mean, you are all experts at this, yes, you know that, but if you want to do this remotely, if there are rogue APs that were deployed, which were deployed after you did a good planning and site survey and all of that, but something popped in, somebody brought in a printer, somebody brought in a projector, or there were blinds that came on, which had Wi-Fi in that. That kind of stuff, you can now see this through our system. I kind of put this into two categories. There is, I think Sam Clements, who kind of suggested us to come here, there is always the good Wi-Fi design, which you guys are all experts at. We understand that completely. And then there is the operations phase, right? So the operations phase, once you have left the place, now how do you monitor that on an ongoing basis? If there is a problem after you've done an excellent design, something is brought in either by a neighbor or or a employee of the organization, how do you then figure out remotely, can you troubleshoot that location without going in over there? That's kind of the point, over here. So this is the problem solution, kind of the autonomic Wi-Fi piece. The AP tile, I would say this, hopefully some of you will, appreciate. There's a lot of kind of hard work behind that. And what I mean by that is, we all have looked at, the MetaGeek Channelizer, and I'm not knocking on any of those vendors, or even Wireshark packet captures, etc., right? So we do a lot of reverse engineering to figure out, what a unknown access point is, and what I mean by that is, this actually gives you a access point view as opposed to the BSSID view, which is very logical when you are trying to troubleshoot. As an example, if I click on one of these, over here, if this was a thing that was not known to you, then how many radios are there? What are the SSIDs and BSSIDs? This gives you a reverse engineered view of the access point, which is valuable primarily for unknown IPs, right? So we do a lot of back-end correlation. And by the way, all vendors have these funky logic. Meraki does it differently than Aruba, where it's just the last byte, whereas Cisco, which, we found out the hard way, Cisco reuses the MAC addresses, going from 0 through F and F through 0. Once you have more than 8 BSSIDs, you're using the same BSSID on both bands, which all intricacies, of different vendors, when I believe somebody over here asked, what have you done vendor specific? So there are things like that, which we have all learned over the years from our knowledge, right? Which is all in our head, you guys can figure it out, but if you have call it a novice user using the system, can they make some sense out of the system, or help get to a better state than they were earlier?
All right. So quick question. Why, you have channel listed there, and it looks like a 40 megahertz bonded on radio 2.
Yep.
Is that a P and an S?
Yes, it is. It is our notion convention. You call it good, bad, indifferent, but we call it invented that. Like I said, P is the primary channel and S is the secondary channel. And I know this was not a notion in the industry, but I know myself, when I used to look at that, people would say, oh, I'm using 44 plus 48, but if you have another AP using 44 plus 48, if you've configured differently, then you may have a problem, right? Because there is no
Yeah. So are you capable of distinguishing, say, how much extra contention you're going to get from having, say, 44 plus and 48 minus, as opposed to a
So we do have, yes, to an extent, yes, I would say. So we have this other thing where we call as the RF analytics.
52 minus, I'm sorry.
Yeah. So if you look over here, we actually plot the full airtime utilization, which we split that into interference, data traffic, management traffic, and you can look at that, for each band separately. And you can also see, what were the clients, if there were specific clients that were utilizing greater than 1% channel, we list them. It's like the top 10 talkers in the wired world we talk about. In this case, it is the top 10 talkers, in the Wi-Fi world, but by airtime.
So on interference there, are you pulling that off the spec AN? And if so, do we have to manually shift between what band we want the spec AN on? Or is it inferring it based on?
So we use both, actually. So what we do is we actually are able to get the actual channel utilization, from the chipset, as well as because we are capturing packets 24/7, we actually are able to compute the total airtime utilized by those packets, and anything remaining is your interference.
Well, so how are you doing that? You said based on the packet capture as opposed to the raw energy there, but with non-802.11 interference, that would have to be implied at best. So are you doing a combination of the raw energy and the PCAP or frame cap? Or?
Yes, we are. Yes, we are. So we actually compute the airtime required to send a frame at a given data rate. We compute that airtime. So now for a given time frame, we will figure out how much is the actual .11 packets which were possible to be decoded took, and then we actually take what the radio is reporting as the actual energy. You subtract that, and then you can get the interference.
Are you reconstructing the headers there?
Reconstructing the .11, the headers? Mm-hmm. Yeah, so the decodable headers, we do take a look at them, and the radio tap information tells us, what was actually used to transmit, yes.
The radio tap is what I was asking about.
Yep.
I know it has to be.
Yep, we do. I'll actually show you the, somebody was asking about the PCAPs. So here, we do have historical PCAPs, on the sensor. So this, you can select what sensor you want to look at. You can select which radio you want to grab the packet capture from, radio 1, radio 2, or third radio, which is scanning. And so I can pick any one of them, and I can go back in time. So let's say if I want to capture from Monday, I go there, I can select the hour.
Is it a ring buffer, or is it all event driven where interesting events will be stored longer, but like continuous?
It is a ring buffer.
It is
a ring buffer, and the ring buffer is reasonably large. What happens, did I click? Yeah. So we are continuously storing on the sensor itself. We do not send all of the PCAPs to the cloud right away. What I believe he was earlier asking that, okay, we only get it on demand. So because if we stream all the raw data to the cloud, just the internet pipe would kind of get clogged from the sensor to the cloud. But those are stored on the sensor. If you know or come to know that, hey, on Monday at 9 a.m. somebody reported an issue, you can go to the cloud, say, just like what I did right now, I said, give me a PCAP, from the sensor for this time duration. You can select any duration from 5 minutes to an hour, and you can download the PCAP, and it has all the headers. The other thing, so one would then question, how long can you store it, right? So it all depends upon how busy your environment is, right? You could be doing, 500 packets an hour or second, or you could be doing 10,000 packets a second, And by default, we will save the header information only, okay? Because in most cases, that's what you really care about. But if you do want a full packet capture, you could, meaning with the data frames as well, you can go in here, and you can actually specify, the size of the frames, and you can make it 1514 or 1580, and we will then capture full packets as well. Of course, depending upon your environment and depending upon the storage available on the sensor, it will be shorter duration. However, we have realized that, and knowing the realities of how we have to troubleshoot, like I had mentioned, this sensor actually has a USB port. So you can actually expand the storage on the sensor using a USB drive that we actually, you can buy that as a separate option. So that is, 128 gigabytes of USB flash storage. So now you can go, depending again on your environment, you could go days, weeks, months as well, and also depending upon are you capturing full size packets or header frames only. So that is, I would say, one very, very unique capability of the Wyebot sensor, that you can get historical PCAPs, and which can be very useful for especially the pros, I mean, like yourself. That
So in a consulting environment, could we take a Wyebot? What do you call your APs? Is there a
sensor?
Is it just sensor? You don't have a
Yeah.
Okay. So could we theoretically roll one of those around on a power supply and just use it in spot consulting?
You could.
Like instead of installing it.
Yeah.
I mean, I know we talked about the
Absolutely.
RC, but
Yeah, you could do that. You could do that. I know. That's what I'm saying. See, pro usage versus regular enterprise usage can be different. So yes, you could certainly do that. I mean, if you, like you said, you deployed something, you designed everything perfectly fine, and now a week later somebody complains, you said, okay, instead of me jumping on the plane right away, let me first send the sensor over there, plug it in, and let me take a look if I can maybe decipher, gather some information through those remote eyes.
how close to real time are we then?
So the cloud interface lags by 5 minutes. So what we do is, when I say lag, I mean, you could make it as real time as possible. When we designed the solution, we said we are going to collect data and send it to the cloud every 5 minutes. So on the sensor itself, actually, we are capturing much, almost every 30 seconds. But then we said, what is kind of a right balance? Within 5 minutes, as long as you're able to, 5 to 10 minutes, you're able to come to know how things are. That's reasonable enough.
So is it a reasonable ask for you guys to have a feature, even if it was an add-on, for a more real-time view? If I want to use this as a troubleshooting tool, so I think that's a very
So
relevant.
define real time a little bit
like
more
a
for
buffered
me.
view, like 5 minutes of buffered data, so that way if something happens and you say, hey, it just happened like 2 minutes ago, you can go back and
You can.
that.
You can do that. Yeah.
So that would be
You can do that, right? I mean, so you can go and grab the PCAP, because the PCAP is on the sensor. It's just that it's not being streamed real time, if that's what you meant. And I know, like, it's not like a wild packets, that you are actually seeing as it is happening, but it is definitely getting saved. So on that note, I will tell you, because I think this may help. There were some people who said, oh, can you, instead of saving the PCAP on the sensor, can I do a remote adapter thing,
or cloud, save it to the cloud.
Yes, and I'll tell you why we thought about it. Absolutely, we did. And there were pros and cons to that. So if you have, let's say, 10 or 20 or 50 sensors in a given location, and they're all trying to write to a remote cloud file server, there is no guarantees to the write speed. And that's why, whereby when we are saving, because that's happening so fast, how much data we can capture.
Sure.
And this is, by the way, another thing, when, again, if you compare or look at any other competitor sensor, we have actually tested this sensor in very unrealistic environments, and what I mean by that is we have placed the sensor in a chamber where you had like 300 APs, around it, and we can still process all the data. We have placed the sensor in a chamber where we had like 3,000 devices, client devices around that, and we can still process the data. So we don't start huffing and puffing, with like, 50 megabytes of PCAP or anything like that.
Right.
We can process, it has actually a quad core processor, and that's the reason it is so hefty. And when you were earlier asking Ali, I mean, can we come up with a micro sensor? Yes, we can, but like, what do you compromise, at that cost?
Well, some alternatives are use a USB port, allow it to write to a 128 gigabyte USB thumb drive, or have a local storage that you the data.
I just said earlier that yes, we do have actually the 128 gigabyte.
Okay.
Maybe you not. Yeah, so yes, we do have a 128 gigabyte USB flash drive, and even the research on that was pretty interesting, because You got to make sure that you can read, write, n number of times, that too very fast. So just a standard USB drive doesn't cut it. It's actually a micro SD card with the high endurance and all of that. Go ahead, please.
So we're going PCAP, but
network testing, I want to cover.
Can you, in some way, shape, or form, anonymize the data that you're sending to the cloud? I mean, I want to send my PCAPs, but can I slice them so that I get only the juicy bits, like the headers, and not the content and all of that?
Yeah, by default. Okay, so again, I think, I guess we've been going too fast because it's interesting, good question, which is all very good. So yes, by default, if you look at the screen, by default, we only capture the first 128 bytes of the headers. Because we know, as Wi-Fi engineers, that's where the interesting stuff, juicy stuff, like you said, happens. You can change it to bigger packet sizes, and that will reduce the duration of, because it has, X amount of buffer to store the local packets. And instead of saving up to 24 hours, you may have 6 hours of storage now, but yes. So by default, it's the headers only. And you can change it if you wish to.
And how protected is it in the cloud?
How protected it is?
In the cloud.
So the data does not live stream to the cloud. You have to go click and say, I want for this duration, and then we will ship it to the cloud.
Okay.
Yeah. Do you have a question?
There was a conversation about streaming, different data, for example. Spec in, and is there a way for me to take, or for example, use Wi-Fi Explorer? We all use it. We're all pretty familiar with it. Can I take this possibly in Wi-Fi Explorer, for example, support remote sensors, right? So is it possible for me to send the data from it to Wi-Fi Explorer, or that will show me this?
You could download the PCAP and then do whatever with it if you wish to.
No, I'm talking about for spec end data, for example. If I want to see the spectrum analysis, or
no. So let me, we've been jumping around, which is all good, but let me show you the spectrum analysis piece. So if I select any given sensor, so once you go to RF analytics and go to show historical data, you can actually see. So there are a couple different things. You can see the airtime utilization. You can see the noise floor, which can sometimes be very useful, especially when you are looking at a conference or auditorium or a exhibition hall. Did the noise floor actually change over a period of time? And then here is the non-Wi-Fi interference, right? So here I can look at past day, week, month, and I can click on any data point over here, and then it tells me, oh, there was a microwave oven actually that caused, and what was the channels that were impacted. From when to when did the interference actually happen, and what was the percentage impact of that. So when you said, Ali, that can I take that data, we by design don't want to go into raw data exposure to the user, because the solution is designed not with the engineer in mind. It is really designed for, many times I say it's a solution designed by engineers, not for engineers, for so that you can actually scale. See, it all goes back to our model of simplicity, scale. So all the folks in this room are all experts, but not everybody is, right? All these people here, CWNEs and all of that, not everybody is. So if we provide that raw data, not everybody can make sense of that. Whereas if I tell this, oh, there was a microwave oven, every person hopefully can make sense of that. What was the end goal?
Quick question with the microwave oven then, or interference detection. Do you correlate that to any of the scan data you're receiving? So, there's a microwave oven, but did that affect any clients? Or was it just that the microwave's been detected? Is there a way of correlating it to say, did this interference actually cause an impact to some clients, and which clients were having a bad time because of that?
Yeah, good question. So I would say kind of yes and no. And so the good news is we have the data. And if you look at, another feature of ours, which we call as device forensics, so you can look at any client and then look at, something and click over here to see, was there a problem that happened with this client? Probably if I go in here, So it is possible that some client actually had an issue. Let me see if I can, maybe this particular client did not. But you can So there have been some asked for by our customers, say exactly what you're saying. Can I actually select a time range and sort of overlay, okay, here's what happened on the RF and here's what happened with the client device. We are exploring if we want to build that kind of a view. I mean, there is certainly value in that. The data exists, but it's at different places at the moment. If you would say, there is data about, okay, yep, this is the time when Bluetooth or microwave oven happened. But then if you look at, client device or a specific device, this is when, the RF interference or a specific client experienced an issue.
Yeah. I just think if you've got that data and you're talking about, I think mentioned in the introduction about having sort of AI analytics to that data. I think being able to say, look, this interference source exists, but actually it didn't affect any clients. But then that's good news to me. Or being able to say, actually, this happened, but it did cause a problem, and it caused poor performance for these clients. I think that would really add value if we could get to that level of data analysis.
Certainly. No, that's understandably, yes, good feedback. One thing I would say, on the network test piece, which that is part of the synthetic network testing, so we offer many different kinds of tests. You're probably familiar with many of them, the standard ping application, etc. One test that I would specifically want to talk about, or a couple I should say, is, so we made this link doctor test, which is a trademark test for Wyebot. But essentially the purpose of this test is primarily to test, kind of VLAN forwarding, IP addressing, and all of that. So if you actually have a problem happening remotely, right, and you want to see, you've configured every AP, but maybe one of the AP's switch port wasn't configured properly, right? So you're trying to figure out, oh, that BSSID, if I connect, I can connect to this AP, but I cannot connect to that AP, even though it's the same SSID, but why is that? Because maybe the switch port wasn't configured properly, right? So that is kind of the purpose of this link doctor test, which is a 7-in-1 test, can be run on both the wired and the wireless interface. So if I choose this, and I can select any SSID. So here's the interesting part of that. With this link doctor test, you can actually test up to more than one access point. You can test up to 6 access points around you. So if I say test multiple access points, you can then say, I want to test 6 APs around me, and I can choose any number. So let's say if I choose 3 number, I can also select what band do I want the sensor to connect to, 2, 4 only, 5 only, or both bands. So if I say both bands, in this case, the sensor will actually run the test on 3 access points, each of the 2.4 and 5 BSIDs, so 6 different BSIDs, it'll connect one by one. And you would say, and this allows you to test farther away access points as well. And like I said, the purpose is not to test throughput and performance, because we all know if you test a farther away access point, you are going to get lower throughput. But you can find out, whether you can get an IP address, whether you can ping the gateway, all of that. And let me actually show you the result, how it looks like, and hopefully that sets a context for what really we mean by that and why we designed this. So if I go into this link doctor multiple access points, right? So essentially what we are doing is we are making it into a 7-step, process where we are saying, can I connect? If yes, can I, yes, how long did the wireless connection take? What was the radius response time? What was the channel signal strength information, etc. If I got through that step, what was my DHCP allocation time? What did I get? Did I get multiple DNSs assigned to me? If yes, once that step succeeds, we ping the gateway. What is the next step? Again, imagine you are not on site and you are asking a novice user to troubleshoot this problem, right? So you ping the gateway, you ping the DNS, then after that, we automatically ping a very standard 8.8.8, very commonly used. And the reason is you don't require a DNS resolution for this one. So we want to first, you checking, can I just get out to the internet? Once that happens, you can say, okay, can I resolve a host name? And then finally, can I ping the internet as well using the resolved host name? So the point here is this is a 7-in-1 test, and you are testing basic packet forwarding. No throughput, none of that business, is my AP configured properly? Very useful for testing remote sites, right? If you, on the other hand, want to test a specific access point, you can actually also do that as well. If I go in here and I select the link doctor test, and I say I want to do the Wi-Fi only, I pick my SSID, and I can say I want to select a specific access point which is close to the sensor. You pick the sensor, you select the AP, and I say, okay, I want you, Mr. Sensor, to connect to this particular BSID only, and I want to see. So this is where it gets a little bit interesting. You all know that APs do band steering, and everybody has their own secret formula for band steering. So we realize that, and what we actually do on the sensor, we actually make up a locally administered address, so that we use a separate dedicated 2.4 only identity for that access point. Because once the AP comes to know that we are 5 gig capable, it could delay the association responses, etc. So we ran into this and we've kind of solved that. So this is again very unique to Wyebot, that we have this link doctor test, which can test multiple APs. You can also test a specific BSSID as well. Very useful for this VLAN subnet. Can I get an IP address and all of that stuff?
Can we automate, script, webhook, API? What are our options with this? If I want to, let's say, call individual parts of this test arbitrarily, and I have the information. Like, say I have BSSIDs, can I call this in a script, or like do API calls in order through like Pi and stuff I know is in my environment?
So yeah, I kind of understand where you're going. So we do have an API, but that API at the moment is primarily read-only API. So you can fetch all the information. We don't at the moment allow any configuration into the sensor. So what you're then asking is, can I do that through the script? So the answer, real answer at the moment, doesn't mean that it cannot change, will not change. It can be done. But the moment you can fetch data and bring it into a Splunk or something else, certainly. But at the moment, you do that through the user interface.
Would you describe this as API first, an API first type environment, whereas anything I can see in the web UI, I can get through the the API?
Yes, you can. Yes, you can. Yes, you can.
You just can't issue the commands.
Yeah, there's no.
So like PCAP, I'll have to generate it right there, but I can download it through API.
Yes.
Okay.
Oh, PCAP, no. At the moment, PCAP, again, that's writing into, because it's kind of creating a request that goes down to the sensor. So that is another request that we've occasionally gotten from people. Can I, fetch PCAPs, through some kind of a CLI? Sorry, you had a question?
Yeah, I had if I could redirect for a moment. Right at the beginning, when Roger was presenting, he said, this is a tool to resolve intermittent problems. Right? Can you show me how those intermittent problems would be displayed? So if I had the sensor, how would I see them? What intermittent problems are you picking up?
Yeah, so there's so much stuff that we glanced over it, So if you look at the tile on the top, which says issue detail, that is actually the piece of our system, which is a very critical piece, what we call as autonomic Wi-Fi. So the sensors are collecting data 24/7, right? And they are sending metadata to the cloud over a secure channel. And the cloud software then analyzes that using an AI engine and then figures out if there is a problem, and then what is the solution to that problem. So this data that you see on the top tile is actually real time, in the sense lags latest at most by like 5 minutes, but that's where you will see problems that would happen. This is what is happening now. And if you want to go back, then you click on the blue button on the top side, which says show historical data. And then you can go back in time and then say, okay, it was Monday at 9 a.m. in the morning. I want to look at what were the problems that were happening at that point in time. So if you get a complaint from the user.
Are you adding new rules all the time, looking at different types of
Yes,
problems?
yes. We are continuously enhancing, and adding new signatures.
And so is there a list of problems that you solve?
So yeah, we don't, so the combinations are, many. So we don't publish because each one of, we use the term signatures, so these are, different kind of conditions. And so it's not exhaustive list published on the website, but you'll certainly see them, in the user dashboard over here. I'll show one or other test, which is kind of an interesting one. So if we go to network test, there is we've added tests for video conferencing, etc. There is a test for measuring DNS performance. So again, this all came back from the fact that we're trying to get to the root cause of the problem. It may not always be Wi-Fi, to Scott's point earlier, it could be something else, and we want to look at every aspect of it, whether it was the DHCP or the DNS. So in this case, as an example, we are essentially, whatever DHCP servers were assigned to the client, we are actually going to resolve, using each DNS server, the resolution time, and maybe sometimes the backup wasn't configured properly, right? I mean, it was missed out, or it hasn't been used, or one of them is loaded, or your load balancing across the DNS server is not working properly. So all of those things, we're trying to look at, again, wired as well as wireless. Goal being, can I reduce the mean time to innocence or mean time to resolution? Either one. So that is, for example, the DNS performance test. We have iPerf test built into the solution as well. Again, very useful. We know everybody is very familiar with iPerf, but if you're trying to troubleshoot a remote site, asking somebody to set up a local iPerf server can be challenging. What we do, on the other hand, you can convert one of the Wyebot sensors into an iPerf server. So you can have two Wyebot sensors kind of going against each other, one acting as a Wi-Fi client, connecting to the AP, then over the wire, going to the other one, and then you can measure. So again, it's all about remote troubleshooting, that you can do. How much of this can you reduce? Couple travel tickets, yes, please.
But you just said something that's very interesting. Do you need to convert your?
No.
It's
When I say
something that can
nope,
run on
nope,
the
nope.
sensor
Sorry.
too?
Okay, so yeah,
I'm sorry.
that does not
maybe
mean
it was a
convert.
slip.
That just means you can use. Let me rephrase. You can use one of the Wyebot sensors as an iPerf server.
Okay, so I could ship out two
Yep.
servers and see how my
Yep,
wireless
absolutely.
infrastructure
Yes,
is
absolutely.
doing. Okay.
Yeah. There is no. I know what we mean, because as AP vendors, you got to convert from a standalone AP to a cloud mode AP to a controller-based AP. No, there's no such conversion like that.
It's still your one box solution. You ship it out.
Yep.
You can do those tests.
Yes.
Now that's interesting.
Yeah. No, I mean, simplicity, we really mean it. We really, really mean simplicity. I mean, if you have feedback on that, it wasn't plug and play, we want to hear that. I mean, you plug it in, that's it, you're done. Like, you can ship it to any place where there is no IT personnel, and as long as there is one that just plug into the yellow cable that is internet, it's done. No, there's no serial console, no nothing on this thing, That's, that is our goal.
Not necessarily PoE. It can be powered too.
It can be powered too. Yeah. I mean, generally, most people, I mean, at least that they will have, PoE. I mean, we can, so your question, I believe, I think it was Landon's question, it was around the MAC address, so we do use different MAC address constructed, like, as you can see, here's an E0 that is being used, only if you can see from farther away. So these are different. This is to be able to work around the band steering concept, So there is the real MAC address of the sensor of the Intel radio in there, and then there is the constructed MAC address, which is, as you can see, it is the locally administered bit that has been flipped over here. So when connecting to the network, we will use the different MAC address so that the AP does not attempt to band steer us.
What's our total power draw on this if I want to be mobile?
Power draw, it's about, depending upon which model you're using. So the standard model, which is the 11AC model that can run on standard PoE, the draw is around, steady state about 11.4, if I remember correctly. I'll have to check the numbers again, but I think it's 11.4. And then, of course, if you go to the AX model, it works, but like I think it's in our corner case testing, we found it's best to power it using PoE plus. So it's a little bit, hairline edge over the standard PoE limit. So for customers, we just recommend that we use PoE plus for that.
Well, yeah, they got 3 radios,
Yeah.
all that, yeah.
But
Yeah,
well,
I
but
could
the
see
thing
that.
is, because we are passive, it's much different than a AP, which has to transmit as well.
But you have
So,
multiple spatial streams as
yeah,
well,
yes,
radio
yes,
chains, all
yeah,
that stuff
yeah,
takes
yeah,
up
yeah,
power.
yes, certainly, yeah.
And when's our release for the AX version, sir?
I would say, within the next couple quarters, you should see that.
Thank you.
Yeah.